Today's lesson is about the idea of an arithmetic or geometric series as opposed to a sequence. So yesterday you learned about a sequence. Just quickly here, let's just make a note. A sequence is a pattern. A series equals a sum of the pattern. So what if you were to add it all up? Okay, so not just the pattern, what's the 50th term of the pattern, but to go back to that movie theater question from yesterday, the question would be how many seats are in the theater? Not how many rows are in the theater, but how many seats. So that we know there's a row with 12, there's a row with 14, there's a row with 16, 18, 20, all the way up to 40. How many people could the theater fit? That is a series question because you're adding up all the points in the pattern, and actually leads me to one of my very few but very favorite stories about mathematicians, which is the story of Carl Friedrich Gauss, who as a young kid was told by his teacher to add up all the numbers from 1 to 100. And the story goes that his teacher didn't like Gauss and wanted to keep the kids busy and to leave him alone, so he gave them this task of adding up all the numbers from 1 to 100. And Gauss did it in seconds, and he got the right answer. And people wanted to know how did he do this? And what he reasoned is that if you have to add up the numbers all the way from 1 to 100, 1 and 100 add up to 101, 2 and 99 also add up to 101, 3 and 98 add up to 101, 4 and 97, and so on. And so all the way down to the middle where you have the term 50 and 51, which would also add up to 101, and all he had to do was say there are 50 pairs of numbers, and each of those pairs adds up to 101, so the whole thing is 50-50, right? And of course, I love that story just because, I just think it's wonderful. Anyway, so the sum of the arithmetic series, right, it comes from, and this is a really nice diagram. He says, what if you added up the first term and the last term? You'd get 101. Now, what if you added up that 101 for every term in the sequence, right? You would get 100 terms of 101, which would add up to 10,100, which is exactly 2 times as big as what the actual sum is, because remember, you've double counted all the numbers here, so you have to divide it by 2, and that gives us the formula for the sum of an arithmetic sequence. Take the first term, add to the last term, multiply by the number of terms, and then divide by 2, and that will tell you the sum of any arithmetic series. Now, there is also a formula for the geometric series. Brilliant formula. I think it would be really interesting to try to explain why this works. We're not going to go into why this works, but I just think it's an interesting challenge for you to try. Why would this formula do what it says it will do? What does it say it will do? It says if you take the next term, not the term I'm asking you to count to, but the next term, and then subtract the first term, and then you divide all of that by the common ratio minus 1. And of course the common ratio cannot be 1, because if it's a common ratio of 1, then every term is actually just the same, right? Because you're just multiplying by 1 and 1 and 1 over again. Why does this work? I think this is a fascinating formula, right? How does this work? Anyway, let's use them, since that's what our job is today. So what is the sum of the first 30 terms? So n is 30 right off the bat. Okay, term 1 is 5. Which is also a, right? A is also term 1. Term 30, we don't know yet, is equal to a plus n minus 1 d. We can tell d from looking at the equation is 0.3, because every time you get to the next number, you're adding by 0.3. So term 30 would be 5 plus 29 times 0.3. So term 30 would be, calculus stuff left over there. Okay, so let's make the sequence. So sequence 5 plus 0.3 k. K is all the numbers from 0 to 29. sorry, I should do n minus k minus 1, right? So 5 plus n minus d. And then k is all the numbers from 1 to 30. Okay, so there's all the numbers up to the 30th term. So let's figure out what the 30th term is. We said it was 5 plus 29 times 0.3. The final term is 13.7. Okay, now you can see I've written all the numbers here. 5 counting up by 0.3s all the way to 13.7. So I can just say sum L1, and I know that the sum here that I'm looking for, if I actually manually added up all these numbers, I get 280.5. Now let's show how the sum formula works. The sum formula says you take the number of things you want to sum, divide it by 2, you multiply by term 1 plus term n. Okay, so in our case, we're looking for the sum of the first 30 terms. So it would be 30 over 2 times 5 plus 13.7. Okay, let me just going to move this down a little bit. Okay, so we get sum of the first 30 terms is 15 times 18.7, and that is equal to 15 times 18.7 gives you 280.5. And that is the correct answer. If you add up those 30 terms, that's what you're going to get. It says determine the sum of the first 8 terms of the given geometric series. Alright, now, when you're doing a geometric series, okay, a geometric series, the sum, okay, we said was equal to a bracket t n plus 1, so the next term minus the first term divided by the common ratio minus 1. Okay, and that's what that's what this formula up here says. Right? So sorry, I mixed them up a little bit. I always did it the one with a. Sorry, it should be like this. And or, let's say or a r to the n minus, sorry, it will be a bracket, right, because you're factoring it out. Okay, sorry, I'm with you. This is the way I'm more used to seeing it, so. Oh, why is that not doing a division? Okay, so either one of these are good to use. Again, it just depends on what you know, right? If you know the last term, or the second to last term, you can use this formula. If you don't, then it's just easier to use the original formula, which I think is the one we're gonna stick with. So let's write down what we know. We know we're interested in the first 8 terms, so that means n is 8. Okay, we know that the first term, we know that a is the first term, and that's a 6. We know that the common ratio is a 4, since if you take 24 and divide by 6, you get 4. If you take 96 and divide by 24, you get 4, and so on. So the sum formula says we should take a, which is the first number, 6. Then we do 4 to the power of 8 minus 1 divided by 4 minus 1. Okay, and so what does that tell us? It's 6 times 4 to the power of 8. Yeah, sorry, I don't know that off my head. 4 to the power of 8 is 65536 minus 1 divided by 3. And therefore you get 2 times 65535. And that would be, so d minus 1 times 2. Sorry, e times 2. 131070 is the sum of those first terms. Now again, let's do it manually using GeoGebra. Okay, so what I'm going to do is I'm going to create a sequence. So my sequence is 4. Sorry, it's the number. So let's use our general term. 6 times 4 to the power of k minus 1. I'm just using k instead of n, but you get the idea. And k can go anywhere from the number 1 to 8. Okay, so if you look at all the numbers in the sequence, 6, 4, 96, 384, 1536, and so on, if you add up all those numbers, the sum of all those numbers, you get 131,070, which is exactly what our formula said it should be. Okay, let's try this one. Now this is the same thing. Okay, this is the same thing. Well, sorry, let's write down this, what we know. A is 6, N is 8, except R this time is negative 4, because you can see the signs are alternating, because every time you multiply by negative 4, it would change a positive to a negative and a negative back to a positive. Let's use our formula. S8 would be 6 bracket negative 4 to the 8 minus 1 divided by negative 4 minus 1 on the bottom. Okay, what does this do? This is 6. Now, negative 4 to the 8 is still going to be the same number because it's an even power, right? So 65536 minus 1. Except on the bottom, instead of positive 3, we're going to get negative 5. And so what you get there is you get 6 over 5 times 65535, which is equal to 6 over 5 times 65535, 78,642. Okay, now again, let's just check on GeoGebra. So I'm going to go back to my sequence command. Instead of raising 4 to the power of k minus 1, I'm going to raise negative 4 to the power of k minus 1. So now you see it goes 6, then negative, then positive, then negative, then positive, negative, positive, and so on. And when you add up all those numbers, the sum is negative 78,642, because I forgot that the bottom part here, 6 over, this is still a negative number, right? So I just forgot to include that negative. So the sum is actually a negative here, because the last term that we looked at would be negative. Okay, so again, that's how that's done. Okay, it says determine the sum of each arithmetic series. Now, the first one, we know that we don't know the number of items, which is part of the problem. Okay, we do know, however, that the first term is 31, and we know that the common difference is 4. So the first thing we're going to want to do here is we're going to figure out what term number is 107. So let's use our formula from yesterday. 107 equals a plus n minus 1d. 107 equals 31 plus n minus 1 times 4. Okay, so bring the 31 over to the other side. You get 76 is equal to 4 times n minus 1. 19 equals n minus 1. And therefore 20 equals n. So this is a 20-term sequence. Now, to do the sum, we're going to add up the first 20 terms. We want to do n over 2 times t1 plus t20. Right? So you basically, the number of terms divided by 2, and then the first term plus the last term. So let's write what we know. Okay, so 20 over 2 is 10. The first term is 31. The last term is 107. So there are 10 pairs of 138, which adds up to 1380. And that is the sum of the first 20 terms. Now let's do this in GeoGebra. Okay, so I'm going to make a sequence. Okay, the sequence is going to start with the number 31, and then it's going to do k minus 1 times 4. It's going to use all the numbers k. Actually, sorry, let's just see. Does it work with? I think it works with n. Let's just use n because we're more familiar with it. And then 1 to 20. Okay, now exactly as we predicted, 107 is the 20th term, which we wanted to know. And if we add up all those numbers, we get 1380, right? So exactly what our mathematics said should have happened. Okay, same thing here. A is 13, D is negative 3, N is unknown. We do, however, know that Tn is equal to negative 62. So negative 62 is equal to A plus N minus 1D. Negative 62 is equal to 13 plus N minus 1. Times negative 3, and then we just work it out. So bring the 13 over, we get negative 75 equals negative 3 n minus 1, 25 equals n minus 1, and therefore 26 equals n. So we are looking for term 26. Now, the sum of the first 26 terms would be 26 over 2, 13 plus negative 62, so let's say minus 62. Okay, so sum of the first 26 terms would be 13 times, let's say 13 minus 62 would be 49. So what's 13 times negative 49? Negative 637. So that's what the first 26 terms of that sequence would add up to. Again, let's use GeoGebra to check. So I'm going to do a sequence. It's 13 plus n minus 1 times negative 3. And we want it to go from 1 to 26. So it starts at 13, then 10, then 7, all the way down to negative 62, right? Which is what it was supposed to do. When you add up everything from that list, you get negative 637, which is exactly what we said. Okay, so that's how you use the arithmetic series, even if you don't know how many terms are there. Okay. Yeah. Okay. All right. So let's knock out a few more of these just so you have some more examples. Okay, so we're on number 4. For this geometric series, determine the sum of the first 10 terms. Okay, so n is 10, a is 4, r is 3, because every one is tripling, right? You triple. So then our formula, Sn, is equal to a r to the n minus 1 over r minus 1. Oops. R minus 1 is in the denominator, so we just fill it out. S10 would equal to a, which is 4, 3 to the power of 10 minus 1 divided by 3 minus 1. Okay, so what's 3 to the 3 to the 10 minus 1 is 59048. 59048 over 2, which is 2 times 59048, which is 2i 118096. Okay, that's what I'm saying the first 10 terms would add up to. Again, let's quickly get in the habit of checking them. The sequence this time is a geometric sequence, so we want to do our a value, which was 4, and then 3 to the power of n minus 1. So that's AR n minus 1 is our formula, and we're going from 1 to 10. Okay, so 4, 12, 36, 108 is the right sequence. The 10th term is 78732, and when you add them all up, you get 118096, which is exactly what this says you should get. Okay, for the arithmetic sequence and so on, what is the 20th term? Again, this is pretty easy, right? A is 6, D is 3. Term 20 would be 6 plus 19 times 3. Term 20 would therefore be 19 times 3 is 57, plus 6 is 63. So then you'd go, the sum of the first 20 terms would be 20 over 2 times 6 plus 63, which S20 would be 10 times 69, which would be 690. Okay, there's really nothing to this one. Just very quickly do the check. So 6 plus n minus 1 times, was it 3? Sorry, 6 plus n minus 1, 3, and we want the 20. We want 20 terms, so from 1 to 20. Okay, and you can see the sum is 690, exactly what we said. Okay, for the geometric series, determine the number of terms, calculate the sum of the series. Okay, so again, this would be an example where I think you still need to, so never mind. Okay, so let's look at Tn equals AR to the power of n minus 1. So that's what the geometric series formula says. We know that A is 3, we know that R is 2, and that's just looking at the first couple of terms, right? You have to double 3 to get to 6, you have to double 6 to get to 12. Now, what we don't know, we know that Tn is 3072, so what we're going to do is we're going to say 3072 is equal to A times R to the power of n minus 1, and then we're going to fill in what we know. So 3072 is equal to 3 times 2, times 2 to the power of n minus 1. So we'll divide both sides by 3. We get 1024 equals 2 to the power of n minus 1. Now again, to solve something like this, you need to know that 1024 is 2 to the power of 10. So it can be written, 1024 can be written as 2 to the 10. Remember, if you're not sure how to do that, what you do to figure out how to get a power of, you just divide it by 2, right? You divide it by 2 over and over again, and then you can write it as 2 to the 10. So then you can say 2 to the 10 equals 2 to the power of n minus 1, and therefore 10 equals n minus 1, and n equals 11. And so there are 11 terms in this sequence. To calculate the sum 11 would be a times r to the power of 11 minus 1 divided by r minus 1. So sum of the first 11 terms would be equal to a, which is 3, bracket 2 to the power of 11 minus 1, divided by 2 minus 1. Of course, divided by 2 minus 1 is just 1 itself. So sum 11 is equal to 3 times 2 to the 11 is 2048 minus 1. So sum 11 is 3 2047, and 3 times 2047 is 6,141, and that would be the sum of those terms. Let's double check. So what I'm going to do, I'm going to go back to my sequence formula. My first term was a 3. My common ratio was a 2, so 2 to the power of n minus 1. And I'm not interested in 20 terms, I just need 11 terms. The 11th term is 3072, exactly what we thought it should be. And the sum of all those terms is 6141. Let's just rename this to be... Okay, there you go. Okay, so there's the sum. Okay, given the following information, what is the better deal? Would you rather win $1 million today, or $1 today, $2 a year from now, $4 2 years from now for the next 20 years? Okay, so let's figure out how much is prize 1 worth. Prize 1 is 1 plus 2 plus 4 plus 8 ... 20 times for 20 terms. Okay, so it doubles every day. So let's figure out what we would get on the 20th year. So let's write down what we know. A is 1, R is 2. Term 20 would be a times AR to the power of n minus 1. So term 20 would be a, which is just a 1, so I'm not going to write it, and then 2 to the power of 19. Now, 2 to the power of 19 is 524,288. I guess, so sorry, just to, it's not really clear from this question. Do you get it again in the 20th year, or is it over after the 19th year? You know what I'm saying? Like, so let me just quickly show you what I mean. So today, right? And then I get 1 year from now, 2 years, 3, 4, 5, 6, 7, 8, 9. Do you see what I mean? Where do I stop at 20? Which in which case today is the 0th term? It's a little bit confusing. Let's put that to the side just for the purpose of the question. But what I'm assuming here is that we don't actually get it on the 20th year. That this happens 20 times is what I think the question should say. In any case, the sum of the first 20 terms would be 20 over 2 times the first term plus the last term. Sorry. This is not arithmetic. Sorry, this is geometric. I'm mixing that up. Okay, so sorry. It was AR to the power of 20 minus 1 divided by R minus 1, which, just to fill in what we know there, A is 1, so we can kind of ignore it. 2 to the 20 minus 1 divided by 2 minus 1, which is really just 2 to the 20 minus 1. Now, 2 to the 20 is 1048575, which is 1,048,575. Now, technically you get more if you take prize 1, but as we will find out in lesson 3 and 4, it would be far smarter to take option 2 and invest it. Okay, so I think it's kind of a strange question. They're telling it is worth slightly more, but of course it's spread out over such a long period of time that I mean, why would you wait 20 years to get essentially the same amount of money as you could just get today? It doesn't really make sense. So you should just get it today. Okay, now the last one here is this interesting one. Is this ball thrown into the air, and it rebounds to half of its previous height. Find the total distance the ball travels when it hits the ground for the 6th time. Now, so this is a bit tricky. Let's set up a table just to get ourselves started here. So it has to be dropped, and then it has to hit the ground. So 1, 2, 3, 4, 5, 6. So so let's say bounce number, and then let's say height, or let's say distance traveled. Now, when it hits the ground the first time, when it hits the ground the first time, it has traveled a distance of 10, right? When it hits the ground the second time, it travels a distance of 20 because it was thrown 10 meters into the air from the ground, and then it rebounds to half of its height. So picture it on the ground. So you know what? It might make sense. 2, 3. Let me do it this way. Okay. Before it has gone anywhere, it hasn't moved. Okay. By the time it bounces once, it's traveled a total distance of 20 because it went 10 up and then 10 down. So the next time it only bounces to 5 up and 5 down, which means it travels 10. Then it bounces 2.5 up and 2.5 down. Then it bounces 1.25 up and 1.25 down. Then it bounces even half of that, and finally it bounces half of that. What's 1.25 divided by 2? I always mix this one up. Yeah, 625. 0.625. I should have taken 2 seconds to think about that. Okay, so the total distance the ball travels when it hits the ground for the 6th time. Okay, the first time it hits the ground, it's traveled 20, then 10, then 5, then 2, then 5. So we need to add all these up. Now, of course, this is a fairly small number. You could just add them up. I mean, it isn't that hard once we make this table. But let's use the method we know. So we know A is 20. It's the first term. R is 1/2. If I get through the rest of this year without cursing the formatting in this program. Okay, R is 1/2. Now, the number of terms, we know there are 6 terms. There's 6 bounces, right? So the sum of the sequence, right? The sum of the sequence would be A times R to the n minus 1 divided by R minus 1. Okay? Now, what happens in this case when you do this? The sum here would be A. The first term is 20. R to the n is 0.5 to the power of n, which is 6. So we're doing. Sorry, I shouldn't say s. N should be s6. 0.5 to the power of 6 minus 1 divided by 0.5 minus 1. Okay. Now again, just to clean this up a little bit. 40. Excuse me. So that's getting ahead of myself. 6 minus 1. Now on the bottom you have negative 0.5 because 0.5 take away 1 would be negative 0.5. So we can clean this up a bit. If we get negative 40, and then we get 0.5 to the power of 6 minus 1. So let's figure out what that is. 0.5 to the power of 6, e minus 1 is this number. Okay. Negative 0.984375. So we have negative 40 times negative 0.98375. And when you multiply that number, oh, I forgot a 4 in there, didn't I? Negative 40 times f. 984,375. And when you add those together, you get 39.375. Now again, you should be able to check. If you simply add all these numbers together, you'd get the same thing, 39.375. Okay? So again, it's just an example of a type of question. It's a little bit different, but it really uses a lot of the same information. 39.375 meters traveled in total. Okay? So that's it for today. I want you to try the assignments and again post any questions, and we just got the 2 more to finish.